When we look at benzene, we have to know the mechanism. It's a standard question here, 6 marks. Benzene and other amines can be chlorinated to produce chloroamines, which are used in the manufacture of pesticides, drugs, and dyes. That's the normal blurb you get at the beginning of an exam question. Chlorobenzene, C6H5Cl, is formed by the reaction of benzene and chlorine in the presence of a suitable catalyst, such as aluminium chloride. They've given you the equation. Now, the important bit of the question then, outline the mechanism for the formation of chlorobenzene from benzene and show how AlCl3 behaves as a catalyst. So that's the job that we've got to do. Just shift that out of the way a little bit so we can concentrate on what we've actually got to do. Okay, so for 6 marks this question. Before we start, we need to answer 2 questions. Firstly, what is the name of this mechanism? And secondly, what is our electrophile? Pause. The name of our mechanism is electrophilic substitution. I'm going to put that up there. Keep it there while we're going through. Notice electrophilic spelled only with 1 L. It's important that you get this spelling right because there could be a quality of written communication on this particular question, and the electrophilic and electrophile, you'll need to be able to spell those correctly, as well as substitution. So the mechanism is electrophilic substitution. Substitution meaning, pause, substitution being the replacement of 1 atom on the benzene. The benzene is going to be the hydrogen that is replaced by a chlorine. Our electrophile then, and it's the case for all our benzene mechanisms, the electrophile will be a positively charged ion. An electrophile, of course, can be the positively charged part of the molecule, but generally in our central mechanisms for benzene, this is going to be a positively charged ion. So our electrophile, in this case for the chlorination, is Cl+. Now, we've got to show, crucially, in this question, because it's asked us to outline the mechanism and show how the catalyst is behaving, we've got to show this catalyst. So, it's given us AlCl3. What we've got to do is add it to chlorine, because we've got to be able to form this electrophile. And we will get, pause, AlCl4 minus plus our Cl plus, our electrophile. So that is 1 mark. You've shown the formation of the electrophile. Now, how does this electrophile get involved in the reaction? First of all, you take your benzene ring. Remember, the circle in benzene is a representation of those 6 pi delocalized electrons. And remember, we're not showing any hydrogens on this skeletal diagram. Then, our electrophile, our Cl+, approaches, and we have a curly arrow. Pause, which way does the curly arrow go? Does it go from the Cl+ to the benzene ring, or vice versa? And what does a curly arrow actually show? Pause. Okay, the curly arrow shows the movement of a pair of electrons. Our electrons are in the benzene ring, so the arrow is going to go from the benzene ring to the Cl+, our electrophile. In the next stage of our mechanism, we've got to show our intermediate. Now, it's crucial that we draw our intermediate carefully. As a pair of electrons have been donated to our Cl+, our electrophile, how many electrons are left in our delocalized ring, which has now been broken? There are, of course, 4 electrons. So it's important that you delocalize these electrons over 1, 2, 3, 4, 5 carbons. It must be that your nice and beautiful smiley face goes over 5 carbons. It's of course positively charged because it's donated electrons. Here now you show the bond formed by the chlorine and the bond which is breaking, the bond which is replacing, substituting if you like, which is the H. So the H, where does it come from? Yeah, on the skeletal structure it wasn't shown, but it is there. Now we're showing it to illustrate the breaking of this bond. So my curly arrow must go from a bond in the H back into the delocalized ring. So there's my intermediate, and I'll get 2 marks for that intermediate. 1 for correctly showing this broken delocalized system, and the second for my curly arrow from the hydrogen carbon bond back, or the pair of electrons moving back into the center. I finish my mechanism with my products. I get 1 mark for my products. So here I've got my benzene with the chlorine substituted on, so chlorobenzene. Of course, I mustn't forget that I've got that hydrogen that has, the bond has been broken, and it remains in our mechanism as an H+. Very important you remember that section to get your final mark with. So, just going through, having a look at where we would mark this, we have got we've got 1 mark for this equation. We've got 1 mark here for our curly arrow to the electrophile. We've got 1 mark provided that our smiley face goes over that dotted line. So I've got 1 mark here, and I've got 1 mark for remembering to put on my curly arrow. Finally, I get 1 mark for my products. Now the last thing I need to do is reform this catalyst. To do that, I must take my HCl4 ions, add it to an H+, to reform the catalyst and produce HCl. It's very important that you don't put that HCl on your products for the mechanism. This only comes as you finish this last mark and you reform the catalyst. So there are your 6 marks for that mechanism. Okay, we've had a look at the basic halogenation mechanism. With this exam question, we were using chlorine. But now what I want to do is just step this up a little bit and change this question. So they could ask the same question, but rather than having benzene, let's replace it with methylbenzene. So it's going to be the same mechanism, but with methylbenzene. Does this change the way we form and reform the catalyst? Pause. No. The catalyst is going to be formed and reformed in the same way as it was before. So there you've got the formation of the catalyst. The difference is just going to be the way you draw your mechanism. The mechanism is going to be essentially the same, but you've got to just slightly change your mechanism. So we've got our benzene, this time with our methyl group. I'm using structural formula here, so I'm not going to write CH3 on the end there. Cl plus is still our electrophile, and here it is, curly arrow coming from the ring of delocalized electrons to the Cl plus. So that's the first step of the mechanism. Nothing changed there, we've just added the methyl group on. Now it is in our intermediate that there is a change. So we've got our methyl benzene again. This time in our mechanism, we are not going to go near this methyl group. It's not going to be involved in this mechanism. What it does is that a methyl group is what is said to be 2,4 directing, which means that our substitution of our chlorine for our hydrogen has to occur either point 2, which is here, or point 4. I'm going to substitute one at position 2. So to do this, I'm going to add my bonds as before. So hydrogen now I'm showing, it wasn't shown in the initial skeletal formula, and my chlorine. So my Cl plus is forming a bond. H is going to be having its bond broken. This time then, I take my smiley and I place it so that the open part of the delocalized ring faces the position where the substitution will occur. So here at position 2, because the methyl group is 2,4 directing, my substitution occurring at position 2. It's positive, it's lost those 2 electrons. It's the same, I'm facing my broken ring to the position where the substitution is occurring. I still have to have my 4 electrons remaining in the ring covering my 5 carbons. Don't forget my curly arrow showing the breaking of my CH bond and that pair of electrons returning to reform the delocalized benzene ring system. So that is the only change in the mechanism. Then here we finish the same system. We just have now our chlorine, which is substituted onto position 2. Don't forget, of course, for your product mark, you need to have your H+. Then, as this question has asked us how the catalyst is reformed, we must remember to put in AlCl4- reacts with H+ to form our catalyst again, and HCl